Chapter 13, Surface Areas and Volumes, Exercise 13.2. So before going on to the exercise, let us quickly revise the formulas. Volume of the cuboid, L into B into H. Volume of cube, L cube. Volume of cylinder, pi r square H. Volume of cone, 1 by 3 pi r square H. Volume of sphere, 4 by 3 pi r cube. And volume of hemisphere, 2 by 3 pi r cube. Now let us move on to the exercise. Question number 1. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So let us see the figure. So a cone standing on a hemisphere. So volume of the solid is what? Volume of the cone plus volume of the hemisphere. So radius, both the radius same 1 centimeter and height of the cone also 1 centimeter. So the volume of the solid is 1 by 3 pi r square H plus 2 by 3 pi r cube. So we want the answer in terms of pi. So no need to put the value of pi there. We have to just substitute the values of the radius and H. So 1 by 3 pi into 1 plus 2 by 3 pi into 1. So we will get 1 by 3 pi plus 2 by 3 pi, which add up to 3 by 3 pi, that is equal to pi centimeter cube. Now let us move on to question number 2. Rachel, an engineering student, was asked to make a model shaped like a cylinder with the two cones attached at its two ends by using a thin aluminium sheet. So let us stop here and see the figure first. So it's a figure, and now look the measures. The diameter of the model is 3. So radius is 3 by 2 and the total length of the model is 12 centimeter. So that means the height of the cylinder alone will be 12 minus 2 plus 2, that's 12 minus 4, which will be 8. And the height of the cone is 2 centimeter. Now the volume of the model equal to volume of cylinder plus volume of two cones. So radius of cone and cylinder is same. It is 3 by 2 and height of the cylinder 8 centimeter. Height of the cone is 2 centimeter. So let us apply the values in the formula. Volume of cylinder is equal to pi r square H1 plus 2 into volume of two cones. So 2 into 1 by 3 pi r square H2. So pi r square is common. So that will take out pi r square into H1 plus 2 by 3 H2. So put the values and simplify 222. It will get cut, so it will become 11. Then let us see. So 11 into 3 into 3, 99 by 14 plus into 8 plus 4 by 3 will come. Further on simplification, what we will get? It is equal to 33 into 2, that is 66 centimeter cube. That is the volume of the model. Now let us move on to question number 3. A Gulab Jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 Gulab Jamuns, each shaped like a cylinder with two hemispherical ends with a length 5 centimeter and diameter 2.8 centimeter. Very, very, very sweet and interesting question, right? Okay, so what is given? A Gulab Jamun contains 30% of the volume is sugar syrup in that. So if 45 Gulab Jamuns are there, what will be the volume of sugar syrup in that? So this is the drawing of one Gulab Jamun. It's a shape with the cylinder and both the ends is a hemisphere. So it's given that cylinder, the length is 5 centimeter. That means the total length of the one gulab jamun, that is given as 5 centimeter, and diameter is 2.8. So radius is 1.4, and from that we can get the height of the cylinder also. Now, volume of sugar syrup is equal to 30% of volume of gulab jamun. Okay. So volume of sugar syrup in 45 gulab jamuns will be what? 45 into 30%. That means 30 by 100 into volume of 1 gulab jamun. So first we need to find volume of 1 gulab jamun. So volume of 1 gulab jamun means what? Volume of the cylinder plus volume of 2 hemisphere. That is 2 into volume of hemisphere. So 2 hemisphere will make a sphere. So that means volume of cylinder plus volume of 1 sphere. So here radius of the cylinder as well as hemisphere are equal to 1.4 centimeter. Height of the cylinder equal to 5 minus 2.8, because the radius part here both the side it will go. So it is 5 minus 2.8, which is equal to 2.2 centimeter. So let us find the volume of 1 gulab jamun. So it is pi r square h plus 4 by 3 pi r cube. So pi r square is common. So pi r square into h plus 4 by 3 r. Now let us substitute the values, and on simplification we will get this. Then again on simplification, what we will get? 75.152 divided by 3, which is equal to 25.05 something will come. So we will take only the 2 decimal places. I think 25.051 something, 01 like that will come. So 25.05 centimeter cube. That is the volume of 1 gulab jamun. Now, what will be the volume of sugar syrup in 45 gulab jamun? So we have to multiply this volume into 45, and we have to find 30% of that. So that means 45 into 30 by 100 into 25.05. So on simplification, we get the answer 338.18 centimeter cube. That is the volume of sugar syrup in 45 gulab jamuns. Very interesting question. Now let us move on to question number 4. A pen stand made of wood is in the shape of a cuboid with the 4 conical depressions to hold pens. You can see in the figure. The dimensions of the cuboids are given. The radius of each depression, that means the radius of the cone, and depth, that means height of the cone, that also given. So find the volume of wood in the entire stand. So the figure is this. A cuboid, in that 4 cubes, 4 cones. So we have to find the volume of the wood in the entire stand. So in the wood, the conical shape, it is depression made. So that much part inside the cone, that much part is removed. The wood is removed. So volume of wood in the entire stand equal to the volume of the cuboid, that is the wood piece in the shape of a cuboid. From that we carved the 4 cones. So that volume we have to remove. Then only we will get the volume of the wood in the entire stand. After making the stand, what is the wood in that? So it is volume of cuboid minus 4 into volume of cone. 4 cones are there, that's why. So dimensions of cuboid is given. Radius of cone given. Height of the cone also given. So it is LBH minus 4 into 4 cones are there into 1 by 3 pi r square h. So substitute the values, and on simplification we get the value as 523.53 centimeter cube. That is the volume of the wood in the entire pen stand. Got it? Simplification part you have to do little carefully. That's it. Do not use the calculator. Do with your mind. That is the exercise for your brain. So never use the calculator. So next question. Question number 5. A vessel is in the form of an inverted cone. Its height is 8 centimeter and radius of its top, which is open, is 5 centimeter. It is filled with water up to the brim. When lead shards, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shards dropped in the vessel. Very interesting question. So let us see. So a vessel is in the form of an inverted cone. This is the inverted cone. Okay. Now what is given? Height, radius, all these things are given and it is filled with water. So it's filled with water. Now height given, radius given. Okay. Now what is going to happen when lead shards is dropped into this cone? Surely we know that because it is full of water, water will flow out. How much water flows out? 1/4. See, 1/4 of the water flows out. So that means if you put lead shot like this, what happens? That water flows out 1/4 of the water. That means how many lead shot you have put inside, the volume of that lead shots, that amount of water is going out. That is it. So here the lead shot, it's the shape of a sphere, its radius is given and height of the cone and radius of the cone given. So water flows out equal to 1/4 volume of cone. Okay, let n be the number of lead shot dropped. So 1/4 volume of cone is equal to volume of n number of lead shots dropped into the cone. Is it? That means 1/4 volume of cone is what? 1/4 into 1/3 pi r square h is equal to 1/4 into 1/3 pi into 5 into 5 into 8. That means 50/3 pi centimeter cube. That is the volume of 1/4 of the cone. 1/4 of the cone. And this is equal to the volume of n number of lead shot dropped. So what is the volume of sphere? 4/3 pi r cube. So n number of spheres, their volume will be this into n. So this is the volume of one sphere, that is 0.5/3 pi centimeter cube. Now this 50/3 pi is equal to n into 0.5/3 pi. Pi and pi will get cancelled, and after cancelling what we get? 0.5 n equal to 50. That means n equal to how much? 100. So 100 lead balls are dropped into the vessel. Hope you understood this question. Very interesting question. Now let us move on to question number. Question 6. A solid iron ball consists of a cylinder of height 220 centimeter and base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the ball given that 1 centimeter cube of iron has approximately 8 gram mass. Use pi as 3.14. So figure is very clear. All the informations are given in the figure. So volume of the solid iron ball equal to volume of big ball plus volume of small ball. So let R1 and H1 be the radius and height of the big ball, whereas R2 and H2 are the radius and height of the small ball. So the volume of the solid iron ball equal to pi r1 h1 plus pi r1 square h1 plus pi r2 square h2. So here only pi is common. Now let us substitute the values. Here we will give the value for pi as 3.14, and on simplification we will get the volume as little bit bigger volume, that is 1,11,532.8 centimeter cube. That is the volume, and we need to find the mass of the pole, and 1 centimeter cube of iron has a mass of 8 gram. So the mass is, we have to multiply the volume with 8. So it is 8,92,262.4 gram you will get. So for convenience, let us convert this into gram by dividing by 1000. So the mass is 892.262 kilogram. Is it clear? Okay. Now let us move on to question number 7. A solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter. Okay, so right circular cone standing on a hemisphere. It is placed upright. Upright means that way itself. Upright in a right circular cylinder full of water, such that it touches the bottom. Find the volume of water left in the cylinder. So let us see the figure. So one cylinder, and inside the cylinder this cone with the hemisphere, mounted in a hemisphere, that is kept inside that. So this cylinder has water. So when you keep this right circular cone standing on the hemisphere, when you put that into this cylinder, definitely water will go out. Little bit water will go out. Suppose it is full. So what we have to know is what is the, find the volume of water left in the cylinder. So let us see. Volume of water left in the cylinder will be what? Volume of the cylinder minus volume of cone and volume of hemisphere. Very, very simple. So radius of cylinder, cone, hemisphere, everything is 60 centimeter. That is same. Height of the cylinder is 180, which is H1, and height of the cone is H2, which is 120 centimeter. So volume of water left in the cylinder equal to pi r square H1, the volume of cylinder, minus volume of cone 1 by 3 pi r square H2 plus volume of the hemisphere 2 by 3 pi r cube. So let us remove the bracket. So here pi r square, that is common in all. So pi r square we will take out and we substitute the values, and on simplification we will get, which is equal to, yes, little bit big answer, some calculations are little bit there, so have to do it carefully. All the multiplication and division part have to do carefully. So this is the answer, little bit bigger number. So it's in centimeter cube. So what we can do is convert this centimeter cube into meter cube. How can we convert centimeter cube to meter cube? We need to divide it by 100 into 100 into 100. So 1, 2, 3, 4, 5, 6 decimal place you have to move to the left. So it will become 1.13143 meter cube. And since it is the volume of water, so commonly we use it in liter. So meter cube, to convert meter cube to liter, we need to multiply with the 1000. So this into 1000, so 3 zeros are there. So again the decimal point will move 3 steps to the right. So the answer is 1131.43 liter. Calculation part little bit there. That only you have to do carefully, slowly, without any mistake. Now I think the last question. A spherical glass vessel has a cylindrical neck 8 cm long, 2 cm in diameter. The diameter of the spherical part is 8.5 cm. By measuring the amount of water it holds, a child finds its volume to be 345 cm cube. Check whether she is correct. Taking the above as the inside measurements and pi equal to 3.14. So this is the figure, and let us see all the measures are given here. That is vessel, a spherical glass vessel, cylindrical neck 8 cm. So height of the cylinder is 8 cm and 2 cm is diameter. That means radius is 1 cm and the diameter of the spherical part is 8.5 centimeter. So its diameter will be half of that. That is equal to 4.25 centimeter. So height of the cylinder, okay, 8. Radius of the cylinder, that is 1. Radius of the sphere, 4.25. So I am converting it into a fraction for my calculation purpose to make it more easy. Otherwise, 4.25 into 3 times multiplication, it will be difficult. So 4.25 equal to 425 by 100 or 41 by 4 is 17 by 4. So that way we will do, no, it will be a little more easy. Then child's observation. What is the observation of the child? The water is 345 centimeter cube. Now we have to find the actual volume of water inside that. So actual volume of water in the vessel is volume of cylinder plus volume of sphere. Is it? So it is pi r1 square h plus 4 by 3 pi r2 cube. So let us substitute the values. Pi is common and here also pi we have to take as 3.14. So here also the calculation part is the 17 cube then into 8. So we will get like this. Now 4913 by 48. When you divide, it will come to 102.354. So we will get the answer as 346.51 centimeter cube. That is the actual volume of the water. So the child's observation is somewhat near to that, is it? It is 345, but we cannot say it is correct, somewhat near. So the child's observation is incorrect. The correct answer is 346, a little bit more, 0.51 centimeter cube. So that is the end of exercise 13.2. So see you with exercise 13.3 soon. Till then, bye.